Okay, Assalamualaikum and hi everyone. Welcome back to semester 2 Mathematics SM025. So in this video, we are going to start with chapter 1, which is integration. So these are the learning outcomes that you are going to learn for this chapter, which is we have 4 subtopics. Okay, so I think it is quite long for this chapter, but it's okay. We can do that. So this is the summary for chapter 1, integration. So we are going to separate into 2, which is indefinite integral and also definite integral. So simple definite integral, you are going to integrate from a limit to one limit, from one limit to one limit, and then you are going to get a value. But for indefinite integral, you are going to get something, okay, in terms of x or any variable, plus c. So what is c? We are going to look at that later. So under indefinite integral, we are going to look at how to integrate by using basic rules, how to integrate trigonometry, and techniques of integration. There are 3 techniques of integration. And for definite integral, you are going to do area. You are going to find area of region and volume of region. So that is all for chapter 1. Okay, so let's take a look at your note. So basically, you already learned differentiation. So integration is just vice versa of differentiation. So you know that if you have let's say if you have x cubed, okay, y is equals to x cubed. So if you differentiate x cubed dy over dx, you are going to get 3x squared, right? Like this. So let's say your y is equals to x cubed. So if we differentiate dy over dx, you are going to get 3x squared. Okay, so you know that from previous chapter in semester 1. Integration is just the vice versa of differentiation, which means if you integrate 3x squared, you are going to get x cubed. Okay, so that means integration is anti-derivative. Okay, so as you can see from here, integrate is anti-derivative. Okay, we anti-derivative both sides and you are going to get this thing. Okay, so what does it mean by C? C is a constant of integration. Okay, constant of integration. Wajib kena tulis bila buat indefinite integral. Okay, as I show you earlier, for indefinite integral, when you differentiate, you have to write plus c. Okay, so let's say if you have y is equals to x. Okay, so if you differentiate y is equals to x, dy over dx, you are going to get 1. Alright. Okay, so hence, if you integrate 1 with respect to x, you are going to get x plus c. Okay, that's it. So just take a look at first example here. The question said, show that d over dx, 1 plus x squared power 3 over 2 is equals to this. Okay, so you know how to do your differentiation. So we have d over dx, 1 plus x squared, 3 over 2. So you know that you have to use power rule here. Okay, ingat 4 steps. Power pindah depan, salin balik, power tolak dengan 1, that will get you 1 over 2. Differentiate dalam. Okay, so differentiate the whole thing here, we get 2x. Okay, so simplify, you are going to get this one cancel. We have 3x, 1 plus x square power 1 over 2. Okay, so that differentiate. Okay, so this is shown lah. Okay, the second question asks, hence, find this thing here. Okay, so integral, this is a symbol for integral. We call this integral. Your function dx. Dx means with respect to x. Okay, so as you can see from here, this thing sama dengan yang ini. Okay, so that means tak perlu susah-susah nak guna any method or any technique. We know that integrate 3x 1 plus 3x 1 plus x square 1 over 2 with respect to x will get you equals to, since differentiate this will get this, that means integrate this will get you this. Okay, so 1 plus x square power 3 over 2. Make sure to write plus c. Okay, whenever you do your integral, you have to write plus c, your constant of integration. Okay, so the same thing will happen for question B lah. Okay, just do it by yourself. Okay, so next, let's see basic rules of integration. Okay, so there are few basic rules of integration. Okay, the first rules here is a constant. Okay, you know that when you differentiate y equals to x, differentiate, power kena tambah 1, right? Power kena tambah 1. So macam kalau dia cakap antiderivative, which means kalau differentiate, power kena tolak 1. Okay, so for integration, antiderivative. So sebaliknya daripada differentiation, that means power kena tambah 1 bahagi dengan power tambah 1. Okay, so let's see this example here. Integrate 3. Okay, integrate 3, which means 3 tu sebenarnya 3x power 0 lah kan. So power tambah 1, that will get you 3x power 1 over dengan 1. So that will get you 3x. Okay, whenever you integrate constant, straight away the answer is 3x plus c. Yes, correct, plus c. Okay, whenever you do integral, make sure to write the c plus c. Okay, so the second rules here is power rule. So as I mentioned before, we have to write x n plus 1 over n plus 1. So let's see this example. You have integrate x to the power of 6. That means x power tambah 1, 6 plus 1, we get 7 over 7. Okay, plus c. Okay, so same thing works here. Okay, 2 over square root x. So we can simplify first. Okay, the key to integration is make sure to simplify your expression first. So we have 2x to the power of negative 1 over 2. So just using power rule, we will get 2x negative 1 over 2 plus 1. We will get 1 over 2 over 1 over 2 plus c. So that will get you 4x 1 over 2 plus c. Or you can write it as 4 square root x plus c. Okay, so that is power rule. Okay, so as you can see from this rule here, 4 and 5, constant multiple rules. So if you have a constant here, you can take out the constant. Okay, let's see here 2, you can take out 2. Just easily take out 2 and biarkan dia sahaja. And if you have sum and difference rule, you can separate this thing here, integrate satu-satu. But look at this, caution here. Okay, kalau darab, kita tak boleh pisahkan. Okay, tak boleh integrate satu, wrong. Okay, sama juga dengan bahagi, tak boleh integrate satu. There are methods, sebab tu ada technique of integration, okay, which we are going to learn later. So let's say example 3 here. Okay, this is what I said earlier. You have bahagi something. Okay, there is no quotient rule. Quotient rule is for differentiation. Okay, so as I said, for integral, if you can simplify the expression, simplify the expression first. Okay, so we know this one, we can simplify x square over x square minus 1 over x square. Simplify first. So integrate x square over x square, which is we will get 1 minus 1 over x square. So here you get 1 minus 1 over x square, which means here is x negative 2 dx. Okay, please pay attention. We haven't integrate yet. Okay, so make sure to write this integral symbol. Okay, so now we are going to integrate. So integrate 1, we are going to get x. Integrate x negative 2, power tambah 1 bahagi dengan power. So here is negative 2 plus 1, negative 1 over negative 1 plus c. So just simplify your answer, you will get x plus 1 over x plus c. That's it. Okay, alright. So the same thing for this one, as I mentioned, you cannot integrate 1. Okay, tak boleh. So the only thing that we can do here is to expand lah. Okay, so if you have come across this type of question, you can separate as what we did in the previous example, this example here, or you can expand. Okay, expand or separate. Okay, so now we can expand this, which you will get 6x squared plus x minus 2 dx. Okay, so now just integrate like usual, a constant, salin je constant, x square, so power tambah 1 divided by the power plus x square over 2 minus 2x. Okay, next step is just simplify. You will get 2x cubed plus x square over 2 minus 2x. Apa yang salah dekat sini? Yes, plus c. Bila saya cakap yes, so saya harap kamu jawab lah. Okay, plus c. Okay, when you do it indefinite integral, make sure to write your plus c. Okay, so let's take a look at last example here, c. 1 over square root 1 minus x. Okay, as what we did here, which is kita bawakan dia naik atas kan? Okay, yes, let's do that. Integrate 1 minus x power negative 1 over 2. Negative 1 over 2. Okay, here comes the next rules here. This one, rules number 3. Sama juga power rule, which is kita letak power tambah 1 n plus 1 over n plus 1. But there are something here. Okay, sekarang this thing here dekat dalam ni mesti kena linear. Wajib kena linear, baru kamu boleh guna power rule. Okay, only if this thing here is linear, only you can use power rule. So how to use power rule? Here we have, salin balik the expression. Okay, kita terus buat dekat example ni lah. Okay, so you have something here, ada power. Okay, can we use power rule or not? Yes, because this is linear. Okay, this is linear, so we can use power rule. So how to use power rule? To integrate this, so salin balik 1 minus x, power tambah 1, so negative 1 over 2 plus 1, we will get 1 over 2 over 1 over 2, and ada something lagi yang kamu kena letak, ialah differentiate dalam dia. Okay, so 1 minus x differentiate, we will get negative 1. Okay, plus c. So this is differentiate dalam. Ataupun lebih mudah kalau kamu nampak dia sebagai a. So this is a lah basically. That's why ax plus b, we differentiate ax plus b, we get a. Okay, right. So just simplify the expression here. We will get negative 2 equals to negative 2 square root 1 minus x plus c. Okay, remember, if you want to use power rule for this expression, this one has to be in linear form. Okay, divide by the power yang dah ditambah 1 and darab dengan differentiate dalam. Okay, ini selalu lupa. Okay, selalu lupa. Okay, alright. If you are used to differentiation, saya rasa tak ada masalah untuk kamu buat ini. Sebab kalau kita buat differentiation, okay, contoh, let's say if I have 2x minus 1 power 3. Okay, kita differentiate by using power rule. Ada 4 step, right? Kita ada 2x minus 1, power tolak 1, darab dengan differentiate dalam. Okay, the same thing happen here, only that power kita tambah, differentiate kita bahagikan. Okay, sorry saya tertinggal sini, power pindah depan 3. Okay, alright, the same thing, only that power tambah, power bahagi, differentiate pun bahagi juga. Okay, you have to know that your integration is just your antiderivative. So if you can master your differentiation, you can do your integration. Okay, so let's moving on to this next part. Let's consider this as basic rules as well, which is integration of a rational function 1 over x or 1 over ax plus b. So this one you have to remember, integrate 1 over x, you will get ln modulus x plus c. Okay, sebab apa kita tak naikkan power? Okay, because if you have 1 over x, let's say kita naikkan power, x power negative 1. Okay, we know if we integrate, power kena tambah 1, negative 1 plus 1, we get 0, bahagi dengan 0, which is undefined. So, nope, that is not the method. which is you have to remember integrate 1 over x, you will get ln modulus x plus c. Okay, so this one has to be linear as well. Okay, must be linear. So if you have 1 over x square, simply just buat macam biasa. Okay, if you have 1 over x square, jawapan dia bukan ln x square. Nope, wrong. Okay, this is misconception, mistake yang selalu jadi. If you have 1 over x square, just simplify x negative 2 dx, then just use power rule as usual. Okay, so let's say if you have 1 over ax plus b, the same thing as before, we still get ln ax plus b, only that you have to divide it by differentiate dalam dia. Okay, so a ni maksudnya differentiate dalam lah. Here is differentiate dalam. Saya consider sebagai dalam lah. Differentiate fx contoh. Okay, so again, this has to be linear. Okay, so if you have 1 over x square plus 3 dx, nope, it's not equals to ln x square plus 3 over 2x. Okay, no, wrong. Okay, there are methods to solve that. We can come across that later. Okay, so let's take a look at example 4. We have 1 over 3x. Integrate 1 over 3x. Okay, so back to the basic rules here. We can take out the constant. So let's take out the constant, which is integrate 1 over 3. Integrate 1 over x dx. So you will get 1 over 3. Integrate 1 over x, you will get ln modulus x plus c. Okay, correct. If you do this thing also, integrate 1 over 3x. Let's say if I want to use this one, you will get ln 3x. Okay, there is no problem because this is linear. Ln 3x over differentiate bawah. Okay, differentiate bawah, which is we get 3 plus c. Also the same thing. Okay, 1 over 3 ln 3x plus c. Also correct. Okay, tak ada masalah, sama je. So let's see example B, 3 over 1 minus 3x. Okay, just take out the constant first, easier for us. So 3 1 over 1 minus 3x dx. Okay, so integrate 1 over 1 minus 3x. Is this linear? Yes, so we can use ln. So that will get you ln modulus 1 minus 3x divided by differentiate dalam, which is differentiate this one, we will get negative 3 plus c. Okay, cancel then we get negative ln 1 minus 3x plus c. Okay, so for c, okay, as I said earlier, if you can simplify your expression, simplify first. So we have x4 over x cubed, we get x. 3x square over x cubed, we get 3 over x plus 1 over x cubed. Okay, 1 over x cubed. So integrate x, we get x square over 2. Integrate 3 over x, we have 3 ln modulus x. Integrate 1 over x cubed is next negative 3. That means you will have x negative 2 over 2 plus c. Okay, simplify, we have x square over 2 plus 3 ln modulus x plus x square, x negative 2, or 1 over 2 x square plus c. Okay, don't forget your plus c. Alright. Sorry, this is negative. Kan? X negative, so kat sini negative. Okay, right. So let's proceed to integration of exponent. Okay, tadi rational, so now we do integration of exponent. So if you come across integration of exponent, macam differentiation juga. Kalau exponent, basically the first thing that you have to do is salin balik. Okay, so salin balik. Kalau differentiate exponent x, we get exponent x. Simple, ex plus c. Okay, if you have eax plus b, okay, if this function can be differentiate, so that means salin balik, bahagi dengan differentiate power. Okay, So let's say if you have integrate exponent 3x, the first thing that you have to do is salin balik, bahagi dengan differentiate 3x plus c. Okay, the same thing as differentiation sebenarnya, cuma kalau differentiation kita darabkan. Okay, and here we have exponent but with e as a constant, which is a lah. Okay, the same thing as the differentiation, kena letak ln. Okay, kena letak ln. Okay, so let's just take a look at example 5. So here we have integrate 4 to the power of 3 minus 2x. So you know that this is exponent with 4, okay, as a constant here. So we have 4, salin je balik dulu, for 3 minus 2x. Okay, since kita buat integration, mesti kena bahagi. Bahagi dengan apa? Bahagi dengan differentiate the power. Okay, so differentiate 3 minus 2x, we get minus 2. Okay, since this is not x, bukan e, dia ialah a, so you have to put ln 4. Okay, so sebenarnya kat sini pun kena bubuh juga. Okay, ln e. Okay, tapi kita tahu ln e is equals to 1, so we don't have to write that. Okay, so here we have plus c. Alright, so for question B, we have exponent x plus exponent negative 2x. So differentiate integrate exponent x, simple, salin je balik exponent x, and integrate exponent negative 2x, also salin balik. Salin balik. Since kita buat integration, you have to bahagi. Kenapa pula ni ya? Exponent x plus exponent negative 2x over negative 2 plus c. Okay, dan just simplify your answer. Minus 1 over 2 exponent negative 2x plus c. Okay, for question C, also just simplify the expression first. E5x multiplied by E2x. So indices, your indices, this one should be E7x over 7 plus 3E2x dx. Okay, so indices darab, maksudnya power kita tambah. So 5x plus 2x, we get 7x. 5x minus 3x, we get 2x here. Okay, so now we can integrate exponent, salin balik, or we can just take out the constant here. So that will be E7x over 7. Okay, salin balik, bukan tambah the power. Okay, this is not x, this is exponent, so just salin sahaja balik. So here we have 3e2x divided by 2 plus c. So that means we will have e7x over 14 plus 3e2x over 2 plus c. Okay, sorry, 7 times 7 ialah 49. Terima kasih siapa yang perasan. Okay, so next, question D. What can we do here? Can we use power rule here? Okay, boleh kita buat 3 bahagi dengan 3, boleh ke? Cannot, because this is not a linear. Okay, so this one you can do it by yourself. Try to do this by yourself. For question E, we have 10 to the power of 3x, the same thing as this one here. You can do it by yourself. This is the answer, 10 3x over 3 ln 10 plus c. Okay, alright, so that is for exponent. Okay, remember exponent just salin balik bahagi differentiate power. Okay, alright, so last part for this video here, we have the integral of e fx and fx power n plus 1. Okay, so this is actually a special case, which is ada teknik dia untuk buat, tapi this is the easier part lah to do. Okay, so let's take a look at question B first. Okay, so 6x squared 2x cubed plus 5 power 6. Okay, so let's see this part here. This one here. Okay, so this is your fx with power n. Okay, so this is your fx with power n, which is if you differentiate your fx, that means if we differentiate this part here, you will get 6x squared. Okay, right? You will get 6x squared. That means your 6x squared is the same as this one. That means this is your f prime x. Okay, so by using these properties here, straight away we will get the answer as 1 over n plus 1. That means 6 plus 1, we will get 7. fx n plus 1. Okay, that means 2x cubed plus 5 power 7 plus c. Okay, so that is like the easier method, if only if you can memorize this 3 formula. Okay, so nak guna boleh, but there are method lagi senang untuk kamu faham lah. Okay, saya ajar je lah dekat sini. Saya tunjukkan contoh satu lagi. Here we have 2x squared plus 1. Let's say this is our fx. Okay, so you know that if you differentiate 2x squared plus 1, you will get 4x, right? You get 4x, which means the upper here is your f prime x. Okay, so if you come across f prime x over fx, straight away the answer is ln fx plus c. So without second look, the answer is straight away ln modulus 2x squared plus 1 plus c. Okay, so that's it. So this is the easy method, only if you can memorize this formula here. Okay, so okay, that's all for this video. I'll see you guys in the next video.